This is a video explaining how to do the interactive truth table exercises for section 7.F.2.I level 1. So I'm just going to take a level the first exercise here. And these exercises are going to ask you to create a truth table, and then after you've done that, comparing two different claims, in this case if T then U and T and U as claims, determine whether those pairs are contradictory, consistent, or inconsistent. So what I'm going to do is I'm going to fill out the truth table first, and I'm going to talk about what it means for them to be contradictory, consistent, inconsistent, and how to evaluate that. So I'm going to go left to right here, and I'm going to look at this statement first. I know that a conditional claim is true in every case, except when the first part is true and the second part is false. So this is the one case where it's false, and these other cases it's true. All right. So this is what I care about now. This is the main operator for this particular claim, and it's true, false, true, true. Now I'm going to go to this one and say, well, this one's true in only one case, when both of the parts are true. So here, it's true in the first case, and it's false in all the others, because they are not both true. All right. Okay, that's the rule for a conjunction. So now what I'm going to do that I've got my main operators figured out here. So I've got true, true, false, false, true, false, true, false. I need to figure out whether this is consistent, inconsistent, or contradictory. So here's how I do that. For an argument, or excuse me, not an argument, these are just two claims. For two claims to be contradictory, that means that when I make their truth table, like they're always flipped. So when this one's true, that one's false. When this one's false, that one's true, so on and so forth. They would have opposite truth values for every line of the main operator for the claims. So that's not what I have here. I've got a couple cases where they're both true, a couple of cases where they're both false, and then a couple of cases where they're flipped. So it's not contradictory. For a contradictory pair of statements, they have to be opposite truth values on every line. So this is a fairly strict one to meet. So this is not contradictory. For an argument to be, or excuse me, a set of claims to be inconsistent, well then they are gonna, it's kind of like contradictory with one exception. An inconsistent set of statements is one where they're never both true at the same time. There's no line in which they're both true. There could be lines in which they're both false, that is, they have the same values, but there's at least no line where they're both true at the same time. So when I look at this one, there is a line where they're both true at the same time. So this is not inconsistent. The hallmark of an inconsistent set of claims is there's no line in that argument where they're both true at the same time. And so inconsistent arguments could be pretty close to inconsistent statements, excuse me, could be pretty close to contradictory statements. The only distinction is that a contradictory one is always opposite truth values. Inconsistent statements can have the same truth values. They can both be false. They just don't have any line where they're both true at the same time. And a consistent set of statements is one where there's at least one line where both of the main operators are true. So here, I've got one line. That's all I need, is just one. So this is, I'm going to mark this as consistent. I've got my two main operators selected here, and I'm going to click submit. And it's going to give me correct. And so that's how you're going to do these exercises. You're going to figure out what the main operator values are, then you're going to compare those main operator values to figure out whether it's contradictory, consistent, or inconsistent.